Hello, boys and girls. This is Alfred Wegener. In 1912, I discovered some evidence to help me to prove continental drift. Today, I'm going to discuss with you how fossils, landforms, ice glaciers, and climate help to provide the evidence I fought so hard for the theory of continental drift. Now, unfortunately, if you look here, I could not tell people why they were moving, but you notice together they are one supercontinent I used to call Pangea. That is number one on the note organizer that I gave you. It is called Pangea, okay? But then they broke apart, and it is called continental drift. It is my theory. And when they broke apart, they moved very slowly, like a fingernail every year. But they moved. But if you look at number 3, I was very angry because my colleagues rejected me. I could not explain what made the continents move. What we now know today is convection in the mantle. If I only had the lava lamp back then to explain my theory, I would be set, but I did not. But I am going to turn this over to Mr. Kirkpatrick to help explain, because he is one of my student geologists. Okay? Boys and girls, enjoy. Hey guys, hope you enjoyed Alfred Wegener. Good to see you. Well, as we already talked about, the continents are slowly drifting apart, and we're going to use FLIC, the acronym FLIC, to help us remember the evidence that Alfred Wegener used. And FLIC stands for fossils, landforms, ice glaciers, and climate. One more time, I'm going to show you. Fossils, landforms, where they might have connected in the past, landforms, mountain chains, ice glaciers on the rocks melting and scraping, and climate, which also affects not only the glaciers melting, but different types of plant fossils found, tropical plants found in colder climates, even some real animals and fossil animals discovered. So let's go through these real quick. If you look at the first one, we're going to start with the fossil evidence. The fossil evidence, okay? Now, the fossils of the Mesosaurus and the Lystrosaurus, which if you look here, the Mesosaurus is here, very cool looking creature, and the Lystrosaurus is here. Strange looking creature, almost like an anteater. What I need you to know is that fossils of these two were found in rocks in not only South America, but also Africa, showing that on 2 separate continents, these once lived. Now, the issue here is that now an ocean divides them, correct? But both of these are freshwater reptiles. So that's a problem because neither of them could have swam across the ocean to get to the other side. So his evidence was saying they must have once been together, being that they're freshwater animals. If you look down here, this is called the Glossopteris, and this was like a fern-like plant. This one actually almost looks like the Glossopteris, if you look at it closely. And this was found in rocks in Africa, South America, Australia, India, and Antarctica. This also proved that these were once together, finding them on different continents, meaning maybe it was once one. Okay, and that's the first part of FLIC, fossil evidence. We're going to now jump to landform evidence. And if you look here, what runs right through our state and all the way up from Maine to Georgia is a mountain range called the Appalachian Mountains. Now, they're very similar because they run up the eastern US, but they're very similar to rock that is also found in Greenland and Western Europe. They found similar rock, similar mountain chains that looked like they actually attached. When you look at the mountain chains, it looked like they were once one, but are now on separate continents, showing a form of evidence through landforms. A mountain is a landform. The other one is there's mountain ranges in Africa and South America also that lined up the same way, that are now separate but on different continents. How is that possible if they were once one to do that across an ocean? The other one here is that there were European coal fields. Coal that matched up with coal fields in North America as well, showing that coal, once a part of a landform, part of the earth, is now separate on separate continents. That is the Ellen flick. And then we have what I call the ice glaciation evidence. And what I have to show you here is I put a little ice cube on top of a rock, okay? And what's happening is it's melting, okay? But as the glaciers moved, okay, as they moved across the rock, can you picture this ice sliding, grinding across the rock over time, long periods of time? They left these deep scratches right here in the rocks that showed that continental glaciers once covered South America. Now, the strangeness to this story is the fact that glaciers develop in cold places, but South America is warm. So if you're seeing these scratches in the rocks in South America, that's showing that there was a glaciation period. At one point, it was cold in South America. And then they also leave these tracks here as they move over the rock surfaces and shape all this land, okay? They leave deposits of sediment and rock underneath as they melt and move. And then what happens is scientists find these deposits of rock down here, like the one that the glacier is sitting on, and they use those rocks to say, hey, if Africa has this type of rock and South America has this type of rock, then those two must have once had similar rocks, similar landforms together that are now separate. So these glaciers not only have scratches, but they leave tracks and deposits of sediment. And that was another one of Wegener's key pieces of evidence, ice glaciation. And last but not least, we're going to kind of be redundant here, but the climate also helped us. So what he found was some warm weather plant fossils here, okay? More plant fossils, same one. And they were found on an island in the Arctic Ocean. Okay, now I don't need you to know the name of the island, but I do need you to know it was in the Arctic Ocean because the Arctic Ocean is freezing. The Arctic is very cold. So if we found a warm weather plant in the Arctic, then that means that must have drifted to the Arctic from a tropical region, showing that climates were different, yet the fossil and plants were the same. This plant couldn't exist in a cold place, so how did it end up there? Another piece of evidence. And the last one was when all of these continents drifted into warmer climates, the glaciers went with them and they melted, as you can see is actually occurring. I don't know if you can see there, but you can see the rock is all wet. It is also melting here, and it's leaving deposits of rock sediment like on the bottom to show that this was once in a warmer climate or colder climate. Okay, so the two ways there are the warm tropical plants in colder regions and the glaciers melting because of climate and leaving deposits of sediment or rock. But the key here is that everyone rejected his idea at the time because he couldn't explain how the continents were drifting. And I put down here a little saying, if he only had a lava lamp to prove his critics wrong, meaning as we look at the lava lamp and we watch the convection, right? Heat rising, cooling, moving out, dropping after it becomes more dense. That is what is the driving force behind plate tectonics, but Wegener did not know that at the time. If you go back up to number 3, he actually, at the end, he said it thought it might have been the Earth's rotation on its axis. And everyone said, no, that's not possible. And it wasn't. But now, 117 years later, here we are knowing about convection, knowing about lithospheric plate movement, okay? Up and out, shifting, and then dropping back down into the Earth to form these convection currents. It's all pretty amazing stuff. But his 4 pieces of evidence, fossils, landforms, ice glaciers, and climate, are all the reasons we even know the continents were once together and now drifted. I hope you enjoyed his little presentation on my evidence. I will ask you now to look at the summarize to see if you can do this to yourself and know about the evidence for continental drift. You are all my student geologists, my paleontologists. Please help me to fight for continental drift.